how do we do this one? Find the domain. This is a very, very important type of problem in your final and exams, because in this whole 131 class, what is our focus? Remember, from day one, we start with the definition of function, right? When you talk about any function, you have to what? You have to understand what is a domain and what is a range, okay? And now we are talking about a rational expression, which is 5x minus 2 over x squared minus 6x minus 16. This is a quotient. When you deal with a rational expression, the emphasis is, in order to be meaningful, the denominator cannot be 0. So when people ask you to find the domain, is to find all the x values that make this function meaningful, right? So if you don't know anything, at least you can tell people, I know what is the domain. The domain is all the values for x such that the denominator is not 0, right? But what is denominator? Denominator is this. Oh, yeah, and we're not done yet.
No, I know, and I did that, but then the answer in the back doesn't match what I got, what I factored out.
Oh, so how did you factor? Can you tell me?
X minus 8, x plus 2.
Very good.
And then x cannot equal
And then x, right? So, very good. So, that means x cannot equal to 8, x cannot equal to negative 2, x is a real number, right?
the answer in the back is x cannot equal 2, x cannot equal 5 halves.
Oh, then that's a mistake. Yeah,
And then
for sure. Okay, good. All right, so
I think you probably copied the wrong number because I thought that.
oh, okay, okay, all right. So,
The actual problem is x minus 2 over 2x squared minus minus. Oh, I did it wrong? Yeah.
okay, but this is a good problem to review anyway. So how do you write this in a interval notation? It will be what? All the points to its left, or between negative 2 and 8, or greater than 8, right? So it is negative infinity to negative 2, union, negative 2 to 8, union, 8 to infinity. Awesome.
When we do it, can we do either that interval notation or the set notation?
When you do it, or when I ask you questions, I will ask you all three of them. This is a set notation. And this is the interval notation.
So we had to have both.
And third, this is the graph on the number line. You need to have both, all three of them. Okay? So when you will answer all three of them. Okay? Wonderful, wonderful. Okay, who asked this question? This is a wonderful question. I want to see anyone would like to start this one. Give us some idea. Okay. What have you done? Tell me.
1 over 5 plus t.
1.
But s, oh, sorry, 1 over s plus t.
1 over, like this.
Yeah. S plus t.
So s and t are both inside in the denominator. Great job. Thank you, Victoria. Extra credit. It is correct, because it is the whole thing to the power negative 1. If anyone write this as 1 over s plus 1 over t, then it is wrong. Okay, now, Victoria, continue. What do you do with this? Yes, because this is negative 1 power to just s, so it's 1 over s plus 1 over t. Awesome job. Is that okay? If you don't get this right, whatever you do after this makes no sense, right? This is the most important step. Do you know how to write this expression as fractions, complex fractions? Okay? All right. Now, you have two methods that you can do, right? Either you consider this as a long division, or you can multiply both numerator and denominator by its LCD. Yes.
You all want donuts.
Okay, so what would you like to do? What would you like to do? Reciprocal, you would like to do the long division? Let's try both. We can do both, okay? So the method one, okay, you want to try the long division first? Okay, so let's consider this is a long division line. So you will have 1 over s plus t divided by the whole denominator, 1 over s plus 1 over t. This is method whatever a, okay? Now, this is 1 over s plus t. You would like to write this as a single fraction. So, do they have the same denominator? No. So what would you like to do? Find the common denominator. What is the common denominator for these two? st. So you need to multiply this by t over t. And here you need to multiply this by s over s. So they both have st as common denominator, right? So now what do you have? It will be st in the denominator, and then the numerator will be t plus s. Yes? Now you are happy because this is a division, right, of two rational expressions. So you just change division to multiplication of its reciprocal. Are you with me? Okay? So what do you have? It is st over s plus t times t plus s. Well, that's the same. So s plus t squared. Is that okay? This is s plus t times t plus s, right? Yes? And they're the same, so I put it square. No. This is multiplication. Numerator times numerator. Denominator has to time denominator. No, not just one s plus t. It has to be s plus t times t plus s, which is s plus t squared.
Only when you're adding or subtracting.
When you add or subtract, the common denominator will be your denominator. But when you multiply, you have to multiply across. It's just like, how do you multiply 1/2 times 1/2, right? I'm going to eat half of the pizza, and you say, oh, it is 1/2. That's wrong, right? This is wrong. Is that okay? Okay, you have to multiply all the numerators, and you have to multiply all the denominators. Is that okay? So this is st over s plus t squared. Thank you, Victoria. Good question. Now that is your method 1. How about my method 2? You can say, well, instead of doing this, I can multiply both sides by the same LCD. What is LCD for this case? This is s plus t for the denominator. This is s, and that is t. So what is LCD? S times t times s plus t. So 1 over s plus t times s times t times s plus t, right? And here, 1 over s, every term need to times this. So times s times t times s plus t plus 1 over t times s times t times s plus t. Because you need to distribute it, right? Remember? Question. People seem to not quite understand. Do you understand this? Okay, we can go back. That is the numerator, you times LCD. And this is the denominator, you also times LCD. Does it make sense?
Where did you get S times T?
Oh, okay. We try to find LCD. Because I want to multiply the same thing on the numerator and denominator to get rid of the denominator. So I need to find the common multiple. So what is the common multiple of these three denominators? It will be S times T times S plus T. Good question. It is a good question. Why you have this? Because we are trying to find LCD. And then you are going to have what? When you multiply, then this factor will divide out. You get what? ST, right? When you multiply this with that, S will be divided out, so you only have T times S plus T. When you multiply this, you are using the distributive property, right? T will be divided out, so you have what? S times S plus T. Is it okay? Is it okay? Sorry? Which one was better? Oh, you like this? Oh, okay. Yeah, I know. But it depends on the problem. Yeah. So this will have TS plus T squared plus S squared plus ST. Okay? So far, so good? All right. Now, let's see. Can I combine them? Can I, you know what? Maybe I will back up a little bit, and I will ask you questions. My friend, look at these two terms. You have two terms in the denominator. Do they have things in common? What is that? S plus T. So you don't want to expand it right away. You probably would say, oh, Dr. Chen, we have common factor. Let's factor it. Then by distributive property reversely, you will have S plus T times S plus T, right? And that's exactly what we have here. ST over S plus T squared. Aren't they the same? Yes, right? You can use this way or you can use that way. Some people I heard that you like this way better, but it depends on the problems, you know? You need to know both. Okay. I think this is a good ending for the expression, rational expressions. And I would like to start the chapter 6. Okay, can I have you look at chapter 6 now? You have another part of the learning before the midterm, which is radical expressions, okay? And that is something you learn, but you may have not had good, foundation yet. We are going to have a full learning this time. Let's look at this, okay? Remember that we have used a lot of expression in logarithm with rational exponent. What is a to the power 1/2? That is what? Square root of a. What is a to the power 1/3? It is cube root of a. Now we are going to learn all kinds of rational exponent. Okay? We are going to look at the principal nth root of a number. What do you mean by nth root? This means the nth root. N is the index. The n here means the index. Okay? A is called radicand. So when you write nth root of a equals to b, it means what? A equals to b to the power n. Okay? For example, square root of 121 is 11. Why? Because 11 squared is 121. Is that okay? This is very straightforward to all of you. Now, what is the cube root? Cube root of negative 1,000. So you are thinking, what is the number when you cube? You get negative 1,000. So first of all, let's look at this negative sign. A lot of students, scared looking at this negative sign inside the, radical sign. First of all, you are trying to find some number. That number, you multiply itself 3 times and you get negative. So that number must be positive or negative? Negative, right? Negative number, multiply negative number, you will get negative. So if the index here is odd, is 3 odd? Yeah. So negative number multiply itself all number times. It will be still what? Negative. So it is okay to have negative number inside the radicand if the index is odd. Does it make sense? And then the result will be also negative. However, if this is a square root, and I have negative sign for 121, will that be okay? No, because what? You will not have any real number. You multiply it itself, means squaring, and you will get negative, right? Any number squared, you get positive or 0. So if the index is even, like 2 or 4 or 6 or 8, the radicand has to be positive or 0. Does it make sense? Yeah. Okay, so now you tell me. What is the number? You multiply itself 3 times, you get 1,000. What is that number? 10. So what is the number for B? Negative 10. Does it make sense? If it's odd index, inside the radicand is negative, then the result will be negative. Okay? So the number is negative 10, because negative 10 to the power 3 is negative 1,000. These 2 examples are very, very simple, but very, very important to establish your concept of general nth root. So one more time. If the index is even, the radicand has to be positive or 0. So what about if I have negative number as a radicand? Then you say the answer is not a real number. It's not a real number. Is that okay? If the index is odd, and inside the radicand is also, is negative, then the result will be negative. Is that okay? Okay. All right, so that's what just conclude what we say. All right? What did we say? We say, if the index is odd, okay, then when you have a to the power n inside, like earlier, it's negative 10 to the power 3, then the result will be negative 10. But if it's even, then you have to make sure the output is positive, right? Could be also only positive. Then you would put absolute value, and I will show you some examples. For example, for this one, this is what? What is the index? 4, right? The radicand is what? X to the power 4, y to the power 20. So you try to find out what is the fourth root of x to the power 4 and y to the power 20. Then you try to figure out, okay, what will be that? Okay? You see, this is x times x times x times x 4 times, right? What about this? In order for you to, regroup it, you say, well, this is y, because you're taking the fourth root, right? So you need y to the power 4. Every y to the power 4, and then you take fourth root, you will get y, right? But how many of them? 5 of them. Is that clear to you? So the answer will be absolute value of x times y to the power 5th. How do you check? You say, Dr. Chen, how do I check? Well, what is the result if you take this to the power 4? Then you will have power rule, x to the power 4 is x to the 4th. X to the power 5 and then to the power 4, multiply the exponent, you will get y to the power 20. Is that okay? Now, what about this part B? The index is what? 3. It's odd. And inside the radicand is negative. So the result will be negative. Now, 27 is one number to the power 3. 3. Okay? Treats next time. And then a to the power 6. A to the power 6. If you would like to take the cube root, okay, you know a to the power 3 and then to the power, and then take the cube root, you will get 8, right? But how many of them? It's a to the power 2 to the power 2. So the answer will be negative 3a squared. Okay? All right. Now, we are going to define what do you mean by a to the power 1 over n. And you learned that before. If the exponent is rational, then you are going to have a radical expression, right? So a to the power 1 over n is the nth root of a. So a to the power 1/2 is what? Square root of a. A to the power 1/3 is what? Cube root of a. A to the power 1/5 is what? 5th root of a. Is that okay? All right. Anybody did not see this at all before? Okay? All right. But we have learned this throughout, this logarithm and so forth, right? So now you get that build up. This is the definition. All right? Okay. If you did not learn in previous course, now you're learning it. Okay. Now, let's write the result for each problem. What is 16 to the power 1/2? That means what? Square root of 16, which is 4. Okay? Now, what is w to the power 1/4? Is 4th root of w. You don't know w, so that's it. Now, what is the 1/5 root of 3abc? You just put 5th root outside. Am I correct? So what is this? It's just notation, right? It is a notation. It's just a notation. I think most of you have seen this notation, but maybe you did not relate to that notation. Is that okay? Question? All right. So you probably wonder, Dr. Chen, I like this notation. Why you bother to give me the exponential notation? Anybody can tell me why? I love this notation. I love this notation with the radical, that's 4th root. Why you want to use this? Why? Because we have very, very good rules for exponent. when you have a squared times a cubed, what do you get? What do you get? If you have a squared times a cubed, what do you get? Tell me. A to the fifth. Thank you. Right? That works for integer exponent, right? Now you are going to learn. It works for all the rational exponents. So if you have a to the power 1/2 times a to the power 2/5, wow, very odd. And you can say, you know what? Those rules work. So how are you going to say? It is what? A to the power 1/2 plus 2/5. Is that okay? You just need to add them up. Otherwise, the rules will be the same. So let's add it up. What is 1/2? Is 5/10. What is 2/5? Is 4/10. So this will become a to the power 9/10. Is that okay? That is why we want and we love to write the radical expression as exponential notation with rational exponents. Is that okay? And all the rules you learn applies. So actually we can say now, this section becomes so easy. The only thing that's hard, just like what you said, is a little bit tedious. You have to add what? Rational fractions. Just carefully when you do it. Okay? Is that okay? So now let's continue. Can I have you do these 4 problems? Okay? In a timely way? Yes, they want you to write it in a way that you have rational exponent. Are you done? Can I have you quickly check with your neighbors? Okay? What do you get? Okay? For 1 minute. You just check, and then we will go over them. Okay. What did you get? It should be 6x to the power 1/3. Is that right?
Yes.
What about next? It should be 12c to the power 3 and then to the power 1/5. I'm going to do this. I want you to see this is actually equals the whole thing here is 12c cubed. That is the radicand, right? And then outside is to the power, what? 1/5. Is that right? Okay? Oh, so sorry. Okay. This is what I meant. You want to look at this radicand. This is the whole radicand. The whole radicand to the power 1/5. Is that right? Now, the whole radicand involved with the exponent 3. And then to the power 1/5. So this is 12c as the base to the power 3 to the power 1/5. So this is what? Power of power. Remember? What is the power of power rule? You multiply the powers. So you multiply 1/5 with 3, or multiply 3 with 1/5. How do you multiply 3 with 1/5? You get 3/5. Is that right? This one is crucial. A lot of students don't understand this. Do you understand? One more time. One more time. Look at this. The first example is easy. Your radicand is 6x. The index is 3, so it's 6x to the power 1/3, right? What is the radicand here? The radicand here is the whole thing, which is 12c to the power 3. So I put the whole bracket, say that is my radicand, to what power? To the power 1/5. Is that right? Okay. Now you look at this expression. It is, the base is 12c to the power 3 to the power 1/5. So this is to the power and then to another power. You have to use power of power rule. Power of power rule. What is the power of power rule? For example, a squared to the power 3. This is power of power. What do? You multiply the powers. So you get a to what power? 6. So the same way, you multiply the power. Do you know how to multiply 3 with 1/5? Yes. 3 is 3 over 1. 1/5 is 1 over 5. You multiply them, you get what? 3 over 5. Does it make sense? Yes or no? Yes. So now, people will ask you go backwards. You have this, I give you this. Just like log and exponential, you have to be able to convert backwards, right? So this is 12c to the power 3 over 5. How do you write it in radical sign? Then you say, hey, wait a minute. The denominator will go into index. The numerator will go into the power. Does it make sense to you guys? Okay, who would like to say that? Come out and say it. You will understand it. Okay, come here. Oh, the whole class? All right. So everyone want to say at the same time? Okay. So when you have a rational exponent, the denominator will be your, what is the denominator? The denominator will be your index. The numerator will be your power. Is that okay? And the power of the whole thing. Is that okay? This is very crucial. So don't look at this example just like a simple example. This example tells you a lot of things. If you fully understand this example, you understand the meaning of rational exponent. So one more time. when you have rational exponent, the denominator will be your
Index.
the numerator will be your power. Is that okay? All right, so now let's do part C. So what is a part C? That is 2x over y as a whole thing, so you put a parentheses to the power 5 over 6. Yes? And how about part D? As what we said, you have to be very careful. You have a rational exponent, right? Then now you know very well the 3, which is a denominator, will be your index. So it's a cube root, right? Put cube root. And how about 2? 2 will be your power. Don't forget about this parenthesis. It's the power of what? Negative 64. I give you warning. And that is a bloody mistake for most of students that you say, oh, I'm in a rush. So I don't care. I don't need this parentheses. So you don't put the parentheses. And you just put negative 64 squared. Is that right? No, it is wrong. That is wrong if you don't put the parentheses. The parentheses here is very, very important. Because when you put the parentheses here, that means negative 64 times negative 64, right? If you don't put the parentheses, that means what? Negative 64 times 64. Is that right? So these two examples, B and D, are very, very important. Okay, now continue. Cube root of this, how do I simplify it? Okay, the square here is the square of negative 64, okay? And you are going to take the cube root. So I want to add a little bit to this result. How did you simplify from here to here? Do you know? Right, the cube root of 64 is 4, okay? All right, the cube root of 64 is 4, and then you square it, you get 16. We will do more examples. This is what we just said. If you have a rational power, rational exponent, then the denominator is your index, and the numerator will be your power. Okay, so now let's do this. Can you do those? Try it. Is that okay? Can we look at it, and if you have more questions, remember you have a parentheses here for the whole radicand, okay? So that when you square, it's the square of 3 times square of 2 times square of b times square of c. Okay. What about negative exponent? Well, we have done this for a long time. And we always pay more attention to negative exponent. That means what? You need to take reciprocal of this base, right? So what does it mean by 9 to the power negative 1/2? That is 1 over 9 to the power 1/2, which is 1 over square root of 9, and that is 1/3. What is 1 over 25 to the power negative 3/2? Well, if the denominator is an expression involving negative exponent, when you take the reciprocal, you will go up to the numerator. So this becomes 25 of the power 3 over 2. And you have over 1. Of course, you don't need that over 1. Is that okay? The negative exponent makes you take the reciprocal of the base. Therefore, this is going to go from denominator to numerator. Is that okay? Understand? Very, very important. Okay? Any question about this step? What does the negative exponent does? It takes what? Reciprocal, yes.
You're
No, I'm taking the square root. I'm taking the square root. Okay, I can show you. Okay, actually,
So we don't need the parentheses there?
here, I know what you're saying. Is that what you meant? Okay, when you have 525 here, that means what? 5 square. Am I correct? Do you have 5 square? So you have 5 square, 5 square, 5 square. Am I correct? But what is the square root of 5 square? It is 5. So you will get 5 cubed. That's why you get 125. Is that okay?
Yes.
If you like, I can give you more.
Yes, more.
No problem. 5 square.
So what you just did is like an optional way of doing it. We're not required to do it that way, right?
No, you're right. You're right. It is for people who needs to see the expansion to do it. But if you don't need that, you don't need that. Sorry. Can you see? You have 5 square times 5 square times 5 square, right? Every 5 square, when you take the square root, it is what? 5. So how many you have? 3 of them. So you have 5 times 5 times 5. So that is 125. Does it help? So when you have a radicand, you always try to write in a way according to the index. The index is 2, so I try to write in a way what square. So it's 5 square. And then how many of them? I have 5 square, 5 square, 5 square. I have 3 of them multiplied together. And each one, you can get 5, right? Okay. Now we are going to do it right now. You need to turn this in as a group work. Yeah. Yeah. No. Individual paper, but you can work in groups. You need to turn this in as today's work. What are you doing? You should work together. You are thinking something? Something bother you?
No, I don't have the book.
If you are at work and your boss asks you to do something, you don't have the book, you sit there, you're going to lose your job. Come on. This is not acceptable. Okay? Come here. You have to move your chair. Come. Move your chair here. Yes, come. Let her up. Let him go. Something bother you?
No. Why? I love
Yeah.
math.
Sorry?
I love math.
You love math? Okay, I love to hear that. Then show it. Is it okay so far? Yeah, okay.
So can we have the previous test results back? Because
Yes, I do have. Yes. Yeah. We are going to have everyone having that back. Yeah. Remember that I promised you that you will have a chance to improve the grades. You will, and now I'm giving you this test, and I want you to do the correction and bring it back on Tuesday. Okay? All right. Soaring. Okay. Great job. Mena, Nina, great job. Okay. Dong, Henry Lee. Zhong Herney Lee. Is that you? Zhong Huangli. Is that last name Zhong, right? Huang Li, 是不是? Li Zhong. Then what you do? You should put Li in the last name and Zhong Huang in the first name. Okay. Nicole. Can you pass? Thank you. Natalie. Yeah, Natalie Poon. Natalie Poon. Jamie. Jamie. Good job. Michelle. Lena. Try to, correct it. Susanna. Okay, you have to prove it, okay? Tommy. Catherine. Would you please pass? Thank you. Maricela. Try to work and correct, okay? Go to Turing Center if possible. Arturo. Brendan. Would you please pass to him? Good job. Zaya. Justin. Thank you. Could be better, huh? Always try to reach for the top, okay? Brittany? Okay, would you please pass? Thank you. Adam? Okay, I really need you to work hard, okay? Come on time. Nader? Nader? Awesome. Okay, would you please pass? What? It's out of what? It's out of 100. No, you mean this one? This is out of 120 is the possible, the highest one, okay? But let me see. And 110 will be your 100%. Yeah, you get an extra point 10%, so 110 is the Jeffrey. Yeah, thank you. Amber. Alberto. Hee-jun. Sorry, I said it wrong. It's 115 is 100%. 115 is 100%. You can do the division and find out your Victoria. Yesenia.
Wait, so out of 115 is 100%. So 100%?
100%. Oh, you are awesome. Okay. So what did I just tell all of you? You all have a chance to improve your grades, but the first thing will be you make correction and you analyze your correction. Remember I told you how to do the analysis of your mistake. You have to write on a separate paper, and then here is your work, and here is your analysis of your mistake. Okay? You use like what is the property, or what is the product rule, distributive property, or whatsoever that you missed. How do you avoid that? You need to analyze it. Do I make it clear to you? Yeah, why you get it wrong? How can I avoid that? Okay? All right. Tuesday, you need to turn that in. And the homework, okay, and let me tell you, can I have you look at 6.3?
Do you have any more tests? I didn't get my
Lose. Yeah, I saw yours. Okay, hold on. 6.3. Can I have you look at 6.3? 6.3. Okay. I would advise all of you, because it's talking about multiplying, dividing, addition, and subtraction. I need you to start working on this as pre-read 6.3, pre-read 6.4, and you start doing those homework 6.5, and so 6.5. So I will tell you what is the homework, and I encourage all of you start it this weekend. So when you come, so homework, okay? You have 6.1, 6.2 is a regular homework. You have MML. You have textbook, right? And 6.3, 6.4, 6.5, I need you to start doing that pre-reading as before, and I would encourage you to do the homework if you can, okay? Because it's like a pre-reading practice, okay? This is pre-reading. Okay, now, extra tutor or review. Let me say review. Extra review. When do I have it? Tuesday, 9 to 9:40 and 4 to 5 p.m. a.m. here, okay? But 9 to 9:40 is in my office. And then this is here. In the afternoon will be here, but in the morning will be there. Okay. And is that clear? How many of you are coming on in the morning of Tuesday? Okay. When you come, I'm expecting you done with all of this, and I really hope you can start doing these two sections. Can I have emphasis on these two? This is addition, subtraction. Oh, actually start with multiplication, division. Addition and subtraction. Remember, when we do the rational expression, it's not that hard. Okay? For this one, a little bit hard. You just have to pay more attention. So, that's why I need you to start early. Do I make it clear? Start early this weekend. Yeah.
All of this is going to be on our midterm, 6.1, 6.2.
Yeah, but that will, remember I have two parts on the midterm. This will be the last part, okay? So you have time to practice and asking questions. This will be the last part of the midterm. I will give you enough time. The things that you're doing right now will be the second part, in the second part of the midterm, not the first part, okay? Yeah.
So this lecture review is not to review for the midterm, it's to review for chapter 6.
It's a review for, well, when we have a review, we review for the midterm, right? The midterm has everything. You have linear, you have, polynomial, factoring, right? You have log, exponential, right? So Wednesday, you will have log, exponential, and rational, okay? And then Thursday, we will have the radical.
So on the midterm, what chapters is it covering? Wait, you said again Wednesday. What are we covering Wednesday?
Okay, remember? The log? See, we have done this so long, okay? Factoring, right? Okay? Rational, right? What is the last part? Radical, remember? Okay? So, we are going to have these for Wednesday. And radical will be on Thursday. Or Friday. I will see what is the best to help all of you learn.
So
Yeah.
and then all the stuff we're learning on Thursday.
This is radical. This is radical, right? We already done. We just need to get this done.
So there's nothing from the, like we're not learning from chapter unit 0 or unit 1 for the midterm?
Unit 0, Unit 1. Unit 0, Unit 1 is that's a makeup. That's after you've done your correction, then we can talk about that. Yeah. There's no, oh, you mean the unit 0, unit 1. Yes, it's from the exam. It's from that exam on the second part. So the second part here, the radical part, will have your unit 0 and unit 1. That is, but this is it's a light part. It's not a heavy part. Yeah. Okay? I haven't collected yesterday, today, right? Okay. I will collect it next week then. Okay? Next week is giving you more time. Okay? All right. So thank you for your attention. I need your group work. Pass your group work. The work that you're doing right now. Yeah, pass it. You didn't finish it?
I just wrote the notes. I mean, like what you just wrote on there.
Okay, you know what? I want you to have it completed and turning on Tuesday morning. Okay? For that, yeah. Okay?
This one, what are we doing for textbook homework?
For the quiz you gave back?
Hey June. Hey June. Who is Hey June? Okay. I will need you to hold on this, and when we have the midterm, you will talk to me, okay? And I really appreciate if you don't use your cell.
Oh, okay.
Yeah, because we have noticed that for sure.
Yeah.
But next time you are going to bring your treats.
Oh, okay.
Dr. Chen,
Thank you.
for the exam that you gave back, mine has a lot of marks on it. How should I correct it? There's marks everywhere.
On separate paper, your correction always on. Oh yeah, your correction always on separate paper. Yes. Yes.
Dr. Chen, I have a quick question.
Did you take it separately? Did you take it? Oh, that's the reason why. Now I know. I say, what's going on?